everyone, welcome to the second meeting of Food Biotechnology class. I'm Pujiati, lecturer from Biology Education Department, Universitas PGRI Madiun. Today, we will discuss about the potential of lactic acid bacteria isolated from Indonesian fermented food as probiotics. First of all, we need to recall our memories about the lactic acid bacteria and the probiotics. Okay, lactic acid bacteria. Lactic acid bacteria, or LAB, is a group of gram-positive, non-spore-forming, coccus and rod-shaped bacteria. They ferment carbohydrates to almost entirely lactic acid, or we call it homofermentation, or to mixture of lactic acid, carbon dioxide, and acetic acid, and ethanol, or we call it heterofermentation. Other compounds such as diacetyl, acetaldehyde, and hydrogen peroxide are also produced. These compounds contribute to the flavor and the texture of fermented foods and may also contribute to the inhibition of undesirable microbes. Lactic acid bacteria in fermented foods are interesting, not only from their roles in fermenting, but also in promoting positive health impacts. The concept of beneficial health effect of lactic acid bacteria has existed since Metchnikoff in 1908 proposed that acid-producing microorganisms in fermented dairy products could lead to a prolongation of the lifespan of consumers. As we know that many studies have been directed to exploring lactic acid bacteria from other fermented foods as potential probiotics. So, what is the probiotic? Probiotic is a live microorganism that will confer beneficial effects on the host when ingested in sufficient amount. The probiotic bacteria used in commercial products are mainly members of genera Lactobacillus and Bifidobacterium. Probiotic bacteria are usually those bacteria that have adapted to the gastrointestinal environment. This is the presence of various microorganism species throughout the digestive tract. Gastrointestinal system is a resident flora of various microorganisms referred as microflora or microbiota. These are present in varying concentrations throughout the gut. They include species of bacteria, eukarya, and viruses. So many criteria of probiotics, including acid and bile tolerance, survival through the gastrointestinal tract, ability to adhere to intestinal surfaces, and antimicrobial activity. And the functional properties of probiotics including hypocholesterolemic activity, preventing and treating the diarrhea, and altering the immune system. And the mechanism of probiotics are: first, reduction of luminal pH, competition with pathogen for adhesive sites, nutritional sources, secretion of antimicrobial substances, toxin inactivation, and immune stimulation. Probiotic and other functional properties are strain-dependent, and all probiotic strains are unique and different. Therefore, their properties and characteristics need to be well defined. Based on in vitro studies, lactic acid bacteria isolated from Indonesian fermented foods have promising characteristics as probiotics candidates. We move to the Indonesian fermented food, sayur asin, or we call it Indonesian sauerkraut. In sayur asin, based on Kusumawati research, she found the Lactobacillus plantarum SA28K. The potential is to assimilating cholesterol and lowering serum cholesterol in rats. Next is tempoyak. Based on the Pato research, the lactic acid bacteria in tempoyak, there are Enterococcus gallinarum UP9, Enterococcus faecalis UP11 that have characteristics bile and acid tolerance, being able to conjugate sodium taurocholate. Next, we have amandai. The criteria of lactic acid bacteria in mandai are bile salt and low pH tolerance and good adhesion properties. Here, probiotics have shortened duration of diarrhea in rats caused by EPEC infection and induced secretion of immunoglobulin A and immunoglobulin G. The lactic acid bacteria that studies in here is Lactobacillus plantarum MB 427. The research is by Emawati. The next Indonesian fermented food is tempe. Based on Suhartati research, the lactic acid bacteria in tempe has glucosidase activity. The next example is rice tape. Based on Susanti and Kusumaningtia's research, the lactic acid bacteria in tape have a criteria tolerance to 0.3% bile salts, resistant to pH 2.5, antimicrobial activity against E. coli, Staphylococcus aureus, Bacillus cereus. And this lactic acid bacteria in here is Lactobacillus casei F and CC262. The next example is grower. Based on the Jafar research, they found Lactobacillus TGR2 and Lactobacillus plantarum T3 that can inhibit growth of Staphylococcus aureus. In addition, the lactic acid bacteria is also inhibiting Shigella dysentery. The next is Bakasang. Based on the Carmen research, the lactic acid bacteria in Bakasang is Pediococcus acidilactici that has a function as antimicrobial activity against E. coli, Staphylococcus aureus, Pseudomonas fluorescens, Staphylococcus tipimureum, Bacillus cereus. The first one, based on Rahayu research, she found Lactobacillus plantarum Det3 that can inhibit Shigella dysentery, E. coli, and Salmonella typhi. Collado et al. They found Lactobacillum plantarum IS 10506, IS 20506, and Enterococcus faecium IS 27526, IS 23427, and IS 16183. The adhesion process was strain dependent with the most adhesive lactic acid bacteria or Lactobacillus plantarum strain was IS 10506 and reduced pathogens adhesion to mucus. The third one is research by Dharmawan et al. They found Lactobacillus reuteri IS 27560, Lactococcus lactis IS 16183, Lactobacillus rhamnosus IS 7257, Enterococcus faecium IS 27526 that can inhibit the addition of E. coli 0157 H7 to human intestinal mucosal surface. The next one is research by Nyborn et al. They found Lactobacillus plantarum IS 10507 and IS 20506. Its removal of microcystin LR, a cyclic heptapeptide, hepatotoxins, or cyanobacterial toxins. And the next one is Paro et al. Research. They found Lactobacillus fermentum I11 and Leuconostoc subspecies Lactis I2775 that have the characteristics are acid and oxgal or bile tolerance, the conjugate sodium taurocolates, and bone cholesterol. Based on Yuliawati et al. And Aslinar et al., their research about the lactic acid bacteria in Dadi, they found Pediococcus pentaceus and Weissella mesenterides that can reduce stool frequency, lower TNF level, and improve the balance of good microflora in EPEC-induced diarrheal mice. Based on Surono et al., they found Enterococcus faecicum in Dadi that has significantly lowered fecal mutagenicity of rats fed with milk cultured with the isolate. Okay, next Indonesian fermented food is Gatot. Based on the research, the lactic acid bacteria that found in Gatot is Lactobacillus plantarum MUT7 and MUT13. We know that Gatot made from fermented cassava, and based on the research, the lactic acid bacteria in here can inhibit Shigella dysentery. Okay everyone, this is the last examples of Indonesian fermented food, that is kumis. Based on Sai et al. And Antara et al. Research, lactic acid bacteria that found in kumis are Lactobacillus brevis, Lactobacillus acidophilus, Lactobacillus rhamnosus FSM15, FSM22, FSM26, that have criteria are survive in low pH 2.5 for 2 hours, bile tolerance, bile salts, low pH and artificial gastrointestinal foods tolerance, and having good adhesion properties. In addition, adhered and colonized, good mucosa epithelium of rat, reduced cholesterol level of blood serum of rabbits with hypercholesterolemia condition. This studies is using Lactobacillus acidophilus KBC and Lactobacillus brevis KBA. Okay everyone, it covers all today's explanation about the potential of Indonesian fermented foods as probiotics. Thank you and see you in the next meeting.